So, hello everyone, myself Anurag, and I am going to show you how to solve eigenvalues for a 3 by 3 matrix. So, what is a 3 by 3 matrix? 3 by 3 matrix looks like so this is a 3 by 3 matrix. And now, what are the eigenvalues? Eigenvalues are so in the eigenvalues, we have to find the values of lambda. So, use lambda in characteristic equation to solve the eigenvalues or to find the eigenvalues. So, let us take one example. The example is this is the example. So now what we have to do? We have to do to find the values of S1, S2, and S3. Now what is X1? S1 is the value of sum of diagonal. So now what is sum of diagonals? So these are the diagonal values of a matrix. And we have to find the sum of diagonals. Then what is S2? S2 are the sum of diagonal minus sum of diagonal minus are so what are sum of diagonal minus? By skipping this row, these are the diagonal values, okay? By skipping this row, they have to take these values. Then by skipping this element, they have to take these values. And by skipping the third row and third column, they have to take these values. These are called the diagonal minus of a matrix. Then S3. S3 is nothing but determinant of a matrix. So let us solve this example. In this example, they have the values for matrix that are going to rewrite this example. So at first, we have to write this characteristic equation while solving this problem. So let us solve. To write characteristic equation, lambda cube minus 1 lambda square plus lambda plus S3. So at first we have to find S1. So to find S1 is nothing but the values of sum of diagonals. So let's look. So 6. So this is the value of S1. Next, to find value of S2. S2 is nothing but sum of diagonal minus. So diagonal minus R. By skipping this and this, we have to write this. Yes. Next, we have to skip these values and then write these 4 values. Next, last, we have to skip this and these values. Write this value. By solving this, we get the values. This is the 4, 10, 11. So value of S2 is 11. Then at last we have to find the values of S3. S3 is nothing but the, so now we have to find the value of S3. So by not doing the manual steps like adding the values and doing all the stuff, by just clicking the 2-3 steps in Calci, we have to find the values of determinant. So let us see how to find that. So in the Calci, we have to go into the mode, then select the matrix mode, press 1, then press for 3 by 3, that is 1. Then enter your whole matrix in this system. Our matrix is 4, 0, 1, minus 2, 1, 0, minus 2, 0, 1. So this matrix will get saved in your Calci. Then press AC, then select shift plus 4, then select the determinant, which is at value 7. Then again press shift and 4, then select your matrix, that is matrix A, by pressing 3 and then enter. This will show your value of determinant, that is 6. So as we saw the value of determinant, that is 6, or 3 is equal to 6. So we have got the value of S1, S2 and S3 as well. Next step is simple, just put all these values into this characteristic equation. Now we'll put these values into characteristic equation. So we'll just write the equation over there. Minus S1 minus square plus S2 lambda minus S3 is equal to 0. So now we have to do, just put these values into this equation. That is lambda p minus S1 by 6 lambda square plus S2 11 lambda minus S3 6 equal to 0. Thus we have got this equation. Just put this equation in Calci. Now I'll show you how to put this equation in Calci and get your final answer. So for solving this system of equation in Calci, we have to go in mode, then select equation, then select the system of your equation as it is cube or square. So we have got the system of cube. So we'll select the system of cube, then enter your value one by one. So the value of A is 1, then minus 6, then 11, and then minus 6. So by pressing, we have got the values of x1 is 1, x2 is 3, and x3 is 2. By solving this equation in Calci, we have got the values of lambda, which are lambda is equal to 1, 2. This is the final solution for the eigenvalues. So as you all know, lambda is equal to eigenvalues. So the eigenvalues of this equation A are 1, 2. This is the final solution. Thank you.